Section 7.4 is on properties of logarithms. Here's a little box from your textbook. It says for any positive numbers m, n, and b, where b is not equal to 1, the following properties apply. The product property says that log base b of m times n is equal to log base b of m plus log base b of n. So in other words, if you have two things multiplied that you're taking the log of, you can break it down into addition. Quotient property is similar. So if we have log base b of m divided by n, we can break apart m and n by subtraction. And then the power property says that if I have log base b of m raised to the power of n, I can actually take that exponent and put it out in front. So that's going to be equal to n, which was the exponent, times log base b of m. So let's take a look at several examples here of how to use those properties. So here we have a couple expressions that involve subtraction and addition, and we need to express that as a single logarithm. So here we have log base 3 of x minus 2 log base 3 of 7. So the first thing I'm going to do is deal with my second one here. Since I have that 2 out front, I can move that to the exponent of 7. So that becomes log base 3 of 7 squared. And now because I have subtraction, I can do log base 3. That's going to turn into division of x divided by 7 squared is 49. So log base 3 of x over 49. Number 2 is log base 8 of 48 plus log base 8 of 4/3. So since this is addition, I can rewrite this as multiplication. So log base 8 of 48 times 4/3, which is log base 8 of 48 times 4/3 is actually 64. And if you remember from the previous lesson, we talked about how you can actually evaluate this. So this means 8 to what power is equal to 64? And I know that one, that's going to be 2. So log base 8 of 64 can actually be simplified to 2. So technically I'm not writing it as a single logarithm, but I am simplifying it. Our second set of examples here, we're going to do that backwards. So here I have some logarithms that involve division and multiplication, and I need to expand those. So since this is division, I can rewrite this as log base 5 of 125 minus log base 5 of xy. And since xy is multiplication, I can break that apart and write this as log base 5 of 125 minus log base 5 of x plus log base 5 of y. And notice that I put that in parentheses because I need to subtract that entire quantity. Okay, actually I can do a little simplifying here. Log base 5 of 125 is actually equal to 3 because 5 to the 3rd power is equal to 125. And then distribute that negative minus log base 5 of x minus log base 5 of y. And that's that logarithm expanded. Number 2 here we have log of x squared times y squared times z to the negative 1. I'm going to deal first, and notice there isn't a base. So if I don't have a base, I'm to assume it's base 10. So I'm going to deal with that z to the negative 1. So this is the same as log x squared y squared over z to the 1. Okay, let's break that apart. So I have log of x squared plus log of y squared, because that's multiplication, minus log of z, because that's division. And let's pull off those exponents and put them out front. So that's going to be 2 log x plus 2 log of y minus log of z. And that's what that expression would look like, expanded. You've probably noticed that on your calculator there's a button labeled log. This will evaluate only base 10 logarithms. But as you've seen, we often use a lot of other bases as our logarithms. We can, however, change the base and use a base that we want, for example base 10, using the following change of base formula. So log base b of m is equal to log base c, which is the base that I would choose, whatever base I want, usually 10, log base c of m divided by log base c of m. So we've introduced a different base, and then we just do log of m over log of b. So if we want to evaluate it then and actually come up with a number, we're going to change the base to 10 and use our calculator. So let's go ahead and do that with a couple examples here. So here I have log base 9 of 111. So I can write that as log of 111, and I'm going to use base 10, so I don't have to write the 10, over log of 9. So the bigger number goes on top, the base goes on the bottom, and then I'm going to plug this into my calculator. So hit the log button, 111, and if it opens parentheses, make sure you close the parentheses before you say divided by log of 9, and that's approximately equal to 2.1434. And most of the time we round logarithms to like 4 decimal places. Okay, and that would be my final answer. Let's take a look at this one. So here we would have to rewrite the log of log base 216 of 36 is log of 36 over log of 216. And when I put that in my calculator, I get that it's exactly 2/3. There is actually another way that we could do this, since this one turned out, since I'm seeing some relationship between 216 and 36, I could rewrite this and say log base 216 of 36 is equal to x. And as we did in the previous section, I'm going to turn this into an exponential equation. So 216 to the x equals 36. 216 can be written as 6 cubed to the x, and 36 is x squared. So that means that 3x is equal to 2, or x is equal to 2/3, which is what we found by using the calculator. So in this lesson, we took a look at some properties of logarithms, the multiplication, quotient, and power property, as well as a very useful change of base formula.